there's one more example I want to walk you through with regard to graphing systems of inequalities. And it's like the problem you see in front of you here. You'll find this type of problem toward the end of the homework problems that deal with graphing systems of inequalities. This type of problem gives you the graph or the answer, basically, and then you have to determine which of the systems, the choices that you have, are the correct system, or is the correct system for that picture. Now, what you really don't want to do is take all your choices here and graph them all and then see which one matches the picture they give you. That you could do it that way, but that would probably take much longer than really is necessary. Instead, you just got to be a little clever, a little bit intelligent about how you go about doing the problem, because it's really not that hard. For one thing, when you look at all these different equations or inequalities here, if you think of them as equations, there's not that many different equations there. So one of the first things you might do is just go to those answers and start writing them down as equations. So notice your first answer here written as equations is y equals 2/5 x minus 2, y equals 3/4 x minus 1. Now, if you go to choice B and change it into equations, it's exactly the same thing. So there's no point in even writing that down because you've already got it. Go to answer C, turn them into equations, and now you get something a little different. Y equals 2/5 x minus 1, and y equals 3/4 x minus 2. And if you go to answer D, you get the exact same thing that we already have right there. So this is what typically happens in these problems. Out of all the answers, whether there's 4 or 5 different answers in terms of inequalities, there's typically only going to be maybe 3 or 4 different equations. And the whole point of this is 2 of these equations you see right here must match up with those 2 lines. And once you get them matched up, you're going to be home free because the inequality part is related to the shading. That's very simple to do. So really it all boils down to just get the equations for the 2 lines, pin those down, and you've got it made. Here's the choices you have to choose from. It's got to be from this group right here, because where did that group come from? It came from all the answers there. So 2 of these equations must match up with the 2 lines you see in front of you. And let's see what we have to work with here. Notice that all of our equations are in slope-intercept form. Now, one of the things I noticed about our slopes here, we've got 2 slopes. We've got a 2/5 and a 3/4. Let's think about that for a moment. 2/5 is the slope of one of our lines, and 3/4 is the slope for the other one. Those are the 2 slopes that you see in all the equations that you have to choose from. Now, which of these 2 slopes, 2/5 or 3/4, would be the steeper line? Well, it'd be the bigger number, right? Because the bigger the slope is, the steeper the line is. So 3/4 has to be the slope of the steeper line. Now look at your picture there. Which line is steeper, the green line or the purplish red line there? Which one's steeper? Obviously the reddish purple one, right? That's your steeper line. So this guy right here has to be the slope of the red line. Slope of red line. Because it's the bigger number. And of course that forces 2/5 to be the slope of the green line. You only got the 2 choices there. Not too much to choose from. That's why I'm saying this approach makes your job pretty easy, because there's not a whole lot to choose from. You've only got 2 different slopes. I mean, if you were just guessing, you have a 50-50 shot of getting it right. You don't have to guess, though. Just take the bigger number as the steeper line. All right, now, the rest is going to be very, very easy to do. Take a look at the reddish line there, reddish purple line. Where is it crossing the y-axis? What's that y-intercept? How many points down or tick marks down is it? That's a -2 there. So you're looking for a line whose slope is 3/4, and it crosses the y-axis at -2. So which of those does that? It's this guy right here, isn't it? This guy right here must be the equation for that red line, because it's got everything it needs. It has the correct slope, and it has the correct y-intercept. So we know that that reddish line, the reddish purple line, is y equals 3/4 x minus 2. Now what about the green line? We know its slope has to be 2/5. Where's the green line crossing the y-axis? At about -1. So whereas the equation has a slope of 2/5 and a y-intercept of -1? Right above it there. So that must be the green line. There we go. Okay, so the green line has to be y equals 2/5 x minus 1. So notice, with just a little bit of thinking, we're able to very quickly get the 2 equations for the 2 lines by using our choices. We don't have too many choices to work with, so it doesn't take too long to figure out which of those 2 goes to the 2 lines in the picture. And now we're definitely home free. Let me get rid of this, because the shading will automatically tell us what the inequalities themselves have to be. Remember, when you are trying to figure out which side to shade, one of the options that you have, one of the methods for determining which side to shade is to solve for y, take the inequality, solve it for y. And if you end up with a y less than, that means shade below the line. If you end up with a y greater, that means shade above the line. Well, we're going to use that process here, sort of done backwards, to get our inequalities. Because we know where the shading is, now we'll just figure out what kind of inequality goes with that. So take a look at your green line here. Clearly the shading is below the green line. And so if I shade below, what kind of inequality tells me to shade below the line? A less than type, doesn't it? So you're going to say y less than or equal to 2/5 x minus 1. And with the reddish one, the reddish-purple line, I guess let's call it red, I don't know. It's got a little bit of purple in there, but whatever. Clearly the shading is above that, isn't it? And so what kind of inequality tells you to shade above? A greater than. So if we want to shade above, we do a greater than, or y greater than or equal to 3/4 x minus 2 there. We've already got the 3/4 x minus 2. All we have to do is just change the inequality to a greater than, because we're shading above. And there you are. There is your solution to the system right here. And that then is the easy way to do this type of problem where they give you the picture, the graph, the answer basically, and you have to come up with the system that has that graph for its answer. So just take your answers that they give you, turn them into equations. There won't be that many of them. Even though you have, looks like a lot of choices here, when you change those inequality symbols to equal signs, there won't be but 3 or 4 different equations. That's going to narrow the field down immensely. And then from that, those group of choices right there, those guys, you're going to figure out which ones go with your 2 lines. And that usually doesn't take very long. Use the slope, use the intercept, because these are all in y equals mx plus b format. That streamlines the process. Take a look at how the slopes work. Take a look at what they're crossing the y-axis. It won't take long to figure out which of the 2 equations there go with the 2 lines. And once that's done, you're definitely home free, because the shading then tells you what kind of inequality signs you need. If you need to be shading below, that's a less than. If you're going to be shading above, it's a greater than. And you'll see where the shading is relative to the lines in the graph right there. So that's the simple, the easy way, hopefully, for you to get through a problem like this. Practice a little bit in the homework, and if you have any questions about it, go ahead and let me know. I'll certainly be glad to do more examples of this and help you out.